All right, so we have a given that D is 1/3 of the way from A to B, and we need to find CD in terms of AB and AC. So let's go ahead and mark our important vectors. So we care about CD, so that's our green. We care about AB, that's our red, and we care about AC, which is our blue. So we need to relate all these equations somehow. So if we want to get all of these, then we need to have two different equations with as all of these variables in it, or some way to get these variables in it, because we know a relationship between A, B, and D. So we need to so we can use that to our advantage. So let's go ahead and make two equations. So our purple equation is going to be C to A, and then A to B. So we're saying CA plus AB equals CB. All right. So now let's go ahead and do a similar equation with the same endpoint. So we want CB still, but we're on a different pathway. So we'll make this our orange equation. So we're going to have C to D and then from D to B. So we have CD plus D to B equals CB. All right, so now we can start relating these two and canceling out stuff we don't need. So let's see here. CA, we don't care about CA, but we care about AC. I won't do anything yet. So that's okay to keep in for now, and we'll fix that at the end. Let's see, we want AB, so AB is good to have. And then CB is not helpful because we don't need any part of that. But in our next equation, we have CD, that's helpful. DB is not helpful, but we can relate it to A and B because we know DB here, because A is 1/3 of the way. Sorry, D is 1/3 of the way through AB. So we know that D to B is going to be 2/3. It's going to be 2/3 A to B. And then we have CB again. So what we can do is, again, is another system of equations or cancel out some stuff. So we can add these two equations together. So I'm going to subtract the two equations, I guess. So I want to subtract these two. So then I'm left with CA minus CD plus AB minus DB equals 0. And I want to solve for CD. So I'm going to go ahead and add that CD over. So I have CD equal to CA plus AB minus DB. And again, so we know we can replace CA with a negative AC. So that flips the direction. So now we have AC. AB is fine. And then DB, we know DB is 2/3 AB. So we can say minus 2/3 DB, or sorry, 2/3 AB for our DB, which then makes it simplified down to 1/3 AB minus AC equals CD. So just note what's important, and all three of relate your three important vectors in two different equations with the same overall vector. So in this case, I chose CB because I knew there was a way for me to cancel it out by just subtracting the overall equation. And then I knew I could relate the important vectors in some way because I was given information about A to B in relation to D. But this is a lot of trial and error type problem, so if you mess up the first time, don't get discouraged. Just try again, and eventually you'll get a good relationship that will work, so you get all what you need to solve for the problem. All right, so this next one here is going to be, we have 300 books to sell for 40 each. So I'm going to go ahead and underline, we have 30 books, we're going to sell them for 40 each, resulting in a revenue. So we have revenue of $1,200 for each $5 increase in price. And then we had 25 fewer books are sold. Write the revenue R as a function. Write the revenue R as a function of the number of books of $5 increases. So let's go ahead and write down our equations here. My colorful underlying wasn't that helpful. So let's go ahead and just make one. So $40 each. Let's say equals 1,200. And for each $5 increase, so if you increase your dollars by 45, so let's say 40 plus Y, it's going to be 300. Here, I think it's 300. Okay. $300 minus 25 equals R.